Now, see a question. Let A and B be two sets such that f is a function from A cross B to B cross A. So, here the elements are ordered pairs. Okay, x1 and x2, if I take an element x1, it is an ordered pair. x2, again an ordered pair because it is A cross B. A cross B means it is in ordered pairs. So, f is a function from A cross B to B cross A. Show that f of AB is equal to BA. This is the function that is given. F of AB is equal to BA is a bijective function. So, bijection means what? It is 1, 1 and on 2. So, let's check for 1, 1. Right? I take, let x1, as I told you, x1 is an ordered pair. So, x1 I take it as AB. Okay? And x2, I take it as A dash B dash. Okay, I have taken it as two pairs, ordered pairs. So, x1 equals AB and x2 equals A dash B dash belongs to the domain of the function. Which is the domain of the function? A cross B. Now, what is f of x1? Which is f of AB. What is f of AB? Which is BA. Okay? Sorry. It is ordered pair BA. So, f of x1 equals f of AB equals BA. What is f of x2? F of x2 equals, x2 means what? A dash B dash. F of A dash B dash. What is f of A dash B dash? According to this, it need to be B dash A dash. Okay. So, I have got f of x1 and f of x2. Now, come back. Let x1 and x2 belongs to the domain of the function such that f of x1 equals f of x2. What does this implies? Implies f of x1 is what? BA. BA, ordered pair BA is equal to B dash A dash. Okay? B dash A dash. From this ordered pair, what can I say? This implies B is equal to B dash and A is equal to what? A dash. Right? B is equal to B dash and A is equal to A dash. Now, this implies, what can you say about the ordered pair AB? What is this ordered pair AB? Ordered pair AB is same as A is same as what? A dash. B is same as what? B dash. Right? Ordered pair AB is same as A dash B dash. From this condition I have arrived here. AB is equal to A dash B dash. Now, what is this AB? What is this ordered pair AB? It is same as x1. This is x1 equals x2. I have arrived at x1 equals x2. Therefore, what is the function f? F is 1, 1. I conclude f is 1, 1. Am I clear? Now to check for onto. Okay? Now to check for onto. Let y, so which is again an ordered pair. So y, which is equal to A double dash B double dash belongs to, where does y belongs to? B cross A, the codomain of the function. And x is equal to A dash B dash belongs to where? A cross B. Okay, I have taken y is equal to this ordered pair A double dash B double dash which belongs to the codomain of the function, and let x be a value A dash B dash which belongs to the domain of the function A cross B. Now, how do we prove that onto? We take y is equal to what? F of x, right? Y is equal to f of x. Now, what is y? A double dash B double dash, isn't it? Y is equal to A double dash B double dash. F of x is what? F of A dash B dash. Now, what is f of AB? BA. So, what is f of A dash B dash? B dash comma A dash. Right? B dash comma A dash. Now, this implies A double dash is equal to B dash and B double dash is equal to A dash. Am I clear? These are two ordered pairs. Two ordered pairs are equal means corresponding elements are equal. First elements are equal as well as second element is also equal. So, A double dash is equal to B dash and B double dash is equal to A dash. Now, what is x? What is x? X is equal to what? A dash B dash. Right? X is equal to A dash B dash, which is equal to what is A dash? B double dash, and what is B dash? A double dash. So I have got an expression for x is equal to b double dash a double dash. What does this implies to? Corresponding to every y which belongs to the codomain, there exists what? There exists a b double dash a double dash. Where? In A cross B. Right? B double dash a double dash in A cross B such that f of b double dash a double dash will be equal to what? Y. That is what I need to prove. Let's see. F of b double dash a double dash, f of AB is equal to what? BA. A double dash b double dash. What is a double dash b double dash? A double dash b double dash is y. Am I clear? Corresponding to every y that belongs to the codomain of the function, there exists an expression x. X expression is what? B double dash a double dash in A cross B such that f of this expression, f of x is equal to what? Y. Therefore, since I have got it like y, therefore f is onto. I conclude that f is onto. So, seeing to the function to be 1, 1 and the function to be onto, I can come to the conclusion that this is a bijective function. Am I clear? Okay. Now let's consider another example. See the question. Show that the modulus function f from R to R given by f of x is equal to mod x is neither 1, 1 nor onto. So, we need to show that the modulus function is not 1, 1 as well as it is not onto. Okay, so coming to 1, 1. To check for 1, 1, I take x1, x2 belonging to the domain of the function. Let this x1 be minus 1 and x2 be 1. Right? Now, f of x1 means what? Modulus of minus 1 which is equal to 1. Isn't it or not? F of x2 which is equal to modulus of 1 which is equal to 1. What do you get here? F of x1 is equal to f of x2. But x1 is not equal to x2. So f of x1 is equal to f of x2 does not imply x1 is equal to x2. So what can I say? The function is not 1, 1. Therefore, f is not 1, 1. I repeat once again. As always, x1 and x2 are two values that belongs to the domain of the function. Now, x1 I have taken it as minus 1 and x2 is taken as 1. Now, f of x1 and f of x2, I check for f of x1 and f of x2. I get f of x1 is equal to f of x2. But x1 and x2, are they the same? This does not imply x1 is equal to x2. Here x1 and x2 are not the same. Right? Therefore, f is not 1, 1. Am I clear? Okay. So, coming to the next part, onto function. Now, to check for onto, if you look at, we know that y is equal to f of x is our function. Right? I take y is equal to minus 1. Right? I take y is equal to minus 1. Which implies minus 1 is equal to mod x. What is f of x? F of x is equal to mod x. Minus 1 is equal to mod x. Is this possible? Can the modulus value give me a negative value? No. So, which is not possible? Which is not possible? That is what f is not onto. Am I clear? F is not onto. I repeat once again, to check for 1, 1 and onto for the modulus function. I take x1 and x2 which belongs to the domain of the function, where x1 is negative 1 and x2 is 1. Set of real numbers. Real numbers has both negatives and positives. So, I took x1 as negative 1 and x2 as 1. And when I take f of x1, modulus of negative 1 which is 1. F of x2 modulus of 1 which is 1. Here f of x1 is equal to f of x2 does not imply x1 is equal to x2 as x1 is not equal to x2 here. Isn't it? Therefore, f is not 1, 1. Right? If for any x1, x2 belongs to a domain of the function, f1 equals f of x2 implies the function is what? The function is 1, 1 function. Here you see f of x1 is equal to f of x2 but not for the values of x1 and x2 because they both are the two different values. x1 is 1 and x2 is minus 1. So for x1 equals 1 and x2 as minus 1, f of x1 and f of x2 are the same but x1 and x2 are not the same. So here I say that f is not 1, 1. And here to check for ontoness, as always, y is equal to f of x. That is how we take for ontoness. So y is equal to f of x. Right? Now y is equal to minus 1. Y is equal to minus 1 certainly belongs to the codomain of the function, right? Which is the codomain of the function here? R. So y is equal to negative 1 belongs to the codomain of the function. So y is equal to f of x implies y value is taken as minus 1. Minus 1 is equal to what is f of x? Mod x. Can mod x gives a negative value? No. Therefore, which is not possible and f is not onto. Am I clear? So this function is neither 1, 1 nor onto. Okay. So next, moving on to the next question. Check for f from R to R. F is a function from R to R defined by f of x is equal to 3 minus 4x. 3 minus 4x. We need to show that whether it is a bijection or not. Check for whether the function is a bijection. Okay, so what do you mean by bijection? That is, the function is 1, 1 and onto. If a function is both 1, 1 and onto, it is called as a bijection. Okay, fine. Now checking for 1, 1. To check for the function is 1, 1, I take let x1 comma x2 belongs to the domain of the function such that f of x1 is equal to f of x2. This implies 3 minus 4x1 is equal to 3 minus 4x2, right? So 3 and 3 cancels, which implies minus of 4x1 is equal to minus of 4x2. Further, minus 4 cancels, this implies x1 equals x2. Therefore, what f is what? 1, 1. Right? Now checking for onto. What is onto? You take y is equal to f of x. Right? You write y is equal to f of x. Y is equal to what? What is f of x? 3 minus 4x. Right? 3 minus 4x. This implies 4x is equal to 3 minus y, which implies x is equal to 3 minus y by 4. 3 minus y by 4. What does this mean? This means that corresponding to every y which belongs to the codomain of the function, there exists what? This value. There exists this value. Where does this belongs to? This value which belongs to the domain of the function, such that this value is belonging to where? To the domain of the function. That is, for any y value that I substitute here, I can find a x value. So any y value that's corresponding to every y value belonging to the codomain of the function, there exists such a value that belongs to the domain of the function such that f of 3 minus y by 4 equals what? Equals what? Which is equal to y. Okay? This value for f of 3 minus y by 4 gives you what? Y. Let's check on this. Okay. F of this. What is f of x? What is f of x? F of x is equal to 3 minus 4x. So I can write for f of 3 minus y by 4 is equal to 3 minus 4 times 3 minus y by 4. So 4 and 4 cancels. Then 3 minus 3 plus y. What do you get? Would you get a y? Won't you get a y? Because 3 and minus 3 cancels. I get a y. So what can I say? Corresponding to every y that belongs to the codomain of the function, there exists such an expression that belongs to the domain of the function, such that f of this expression gives you what? Y. Right? So f of this expression is what? X value. This is the x value that I am going to find in the domain of the function. So x value is in this expression such that f of this x value gives you what? Y. Okay, so if so, I can say that the function is onto. Am I clear? Okay. Yes, now let's see another question. Let A is equal to R minus set 3 and B is equal to R minus set 1. Consider the function f from A to B defined by f of x is equal to x minus 2 by x minus 3. Is f 1, 1 and onto. So here again we need to check for whether the function is a bijective function. So right away I am moving into the answer. Checking for 1, 1. How do I check for 1, 1? Let x1 comma x2 belongs to the domain of the function such that f of x1 is equal to f of x2, and I must come to the conclusion that x1 is equal to x2 to show that the function f is 1, 1. Okay, so f of x1 is what? x1 minus 2 by x1 minus 3, which is equal to x2 minus 2 by x2 minus 3. Cross multiplying x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. That is x1 x2 minus 3x1 minus 2x2 plus 6 is equal to x2 x1 minus 3x2 minus 2x1 plus 6. Now 6 and 6 cancels, x1 x2 also cancels. Now minus 3x1, when this comes this side, what will you get? Minus 2 plus 2x1 minus 2x2 plus 3x2 is equal to 0. Now this I get as minus of x1 plus x2 is equal to 0. What does this imply? x1 is equal to x2. Isn't it or not? This implies. Okay. It has an implied sign. So x1 is equal to x2. So I can conclude therefore f is what? 1, 1. So taking f of x1 equals f of x2, I got x1 is equal to x2, therefore f is 1, 1. Now checking for whether the function is onto. How do I check for onto? Y is equal to f of x, right? Y is equal to f of x means what? X minus 2 by x minus 3. That is y into x minus 3 is equal to x minus 2. That is xy minus 3y is equal to x minus 2. Now club the x terms together. That is xy minus x is equal to 3y minus 2. X when taken outside, y minus 1 is equal to 3y minus 2. So x is equal to 3y minus 2 by y minus 1. Just listen, x is equal to 3y minus 2 by y minus 1, and never the value of y is going to be 1 because y doesn't have a 1 there in the set. In the set, y doesn't have a 1 there. Now, from this, what will you conclude? For every corresponding to every y that belongs to where? The codomain of the function, there exists a expression 2y minus 2 by y minus 1. Corresponding to every y belonging to the codomain of the function, there exists an expression in this form such that f of 3y minus 2 by y minus 1 is equal to y. If so, this is 1, 1. This expression, here this expression what you get? F of that expression will give you what? Y. If so, then it is onto. I may check now whether this is the same. What is f of this? f of x is equal to this. On substituting for 3y minus 2 by y minus 1 in x, minus 2 by 3y minus 2 by y minus 1 minus 3. Simplify on this. What will you get? I shall simplify it here. 3y minus 2 minus 2y plus 2 by 3y minus 2 minus 3y plus 3. Right? Now here 3y minus 2y is y. 2 and minus 2 cancels. I get a y here. Now 3y minus 3y cancels. Minus 2, 3, 1, which is equal to y. See, this is same as y. Therefore, what? F is onto. Am I clear? So, once again children, to check for ontoness, one I think it is clear to you. There might be some confusions here, but just go through 2 or more questions, you will understand it in more. So, I took to check for ontoness, I am explaining once again. To check for ontoness, I substitute for y is equal to f of x. F of x is the same expression that is there in the question, and then solving for a required value of x is equal to this. That is, x is written in terms of y. Right? Now corresponding to every y that belongs to the codomain of the function. Actually, what are we checking for? For every value that inside the codomain of the function, I need to find a pre-image. Right? I need to find a corresponding pre-image. Pre-image means what? That is exactly x. Right? Corresponding to every y that belongs to codomain of the function, there exists this expression. This expression gives you what? X. Okay? F of x is equal to y. Right? F of x is equal to y. That is exactly the same as what I have written here. Now, this x expression is in terms of y. That's all. This x expression here is in terms of y, such that you get it as what? Y. I have given the expansion here for you to understand it in fullest. See, this is the expansion of whatever I have written here. Okay, therefore what will I conclude? The function is onto, and hence it is a bijection. Am I clear to what I am saying? Okay.